So, it was a tight start this time. It's just like a real software project. Just shortly before live we discovered some minor problems, this time with the streaming key. But we're live, and for now a very warm welcome to all those present here in our Düsseldorf office. And glad that you can join us. We hope that even more people would come, but I think Corona takes some time, the time after Corona takes some time for everybody to get accustomed to actually meeting people. And actually meeting people has got some big benefits, especially for you present, because we have pizza, we have drinks, we have cool networking possibilities, and amongst all present, a talk or a workshop will be raffled. So for you and your team, you can enjoy a free talk by one of our great speakers of OpenValue, or a workshop will be given. So plenty of reasons to be here in live and in person. Obviously also a warm welcome to everybody who's joined us online via our live stream, and maybe later we'll watch it back. After this day, after this meetup, the talks will be distributed and will be visible via youtube.com/OpenValue, our YouTube channel. And the cool thing about the live stream is that not only those present can ask questions, but we have a live chat there, and we have a close eye on the live chat, so you can post every question that you have on this chat, and we will relay them to the speakers. So, what do we have on? Who do we have on stage tonight? We've got three cool talks. Obviously, I had together with some other colleagues the pleasure of being present at the rehearsals. So it's going to be very cool. Before our break, we will have two lightning talks. Jens Knipper will tell us a bit later about AWS lambdas and how to test them. But the stage is for Christoph to start with, and he's going to tell us everything he learned about MongoDB Time Series. And that's a lot, so it needs to be compressed in 20-25 minutes. So maybe you'll have to chop some things off. But Christoph is a seasoned software developer at OpenValue, and maybe you know him from in that respect, but maybe you also know him from his big hobby. It's game modding, so everybody in the StarCraft world will probably know Ali and Ali Ops, but maybe you tell something about that. So without further ado, the stage is yours, Christoph.
Thank you for the introduction and welcome here. Thanks for coming, and hello to the people at home in the live stream. I'm going to tell you about the MongoDB Time Series feature within the next 30 minutes. So let's not hesitate and start. So let's start. Why am I talking about this? MongoDB's Time Series feature isn't that old yet. It was added in version 5 of MongoDB about 1 year ago, and only a couple months ago it was improved in version 6. The performance is now better, and a few missing features were finally added. And well, why am I talking about this? At my customer, I had the opportunity to use this feature and dive into it, but in the official documentation I did not really find good examples. I had to look a lot of things up and search for clues how to do things. And also, usually you just Google things, then you find blogs and videos explaining things. And in the summer this year, there wasn't a lot to be found. So I decided just create a talk about it after figuring it out. So I've learned a lot, and I want to share my experience with it, so you don't do the same mistakes that I did. So I'm Christoph Ahlers, as you already heard. I'm a software engineer / consultant since 2018, and I joined OpenValue 1 year ago. my hobby is to modify games in StarCraft 2 and Heroes of the Storm. So you've already heard it. Maybe you know me from there. But, well, now I'm talking serious business. So we are programming things. Today we are going to look at the time series feature. Could you turn your mobile phones off to silent mode, please? This is really distracting.
To keep an eye on the chat, sorry.
Thank you. Then, after we have basics, what is time series data or what are time series, we have a look at the time series feature in the Mongo database. And after that, let's check out a live demo where I'm using it in Spring. And in the end, I give you the tips, my knowledge that I've earned in the past few weeks when it was going live at my customer, and of course all the pitfalls that I encountered in the last 2 weeks because things go wrong, unfortunately. So let's start. What is time series data? Well, maybe let's start not that far. What is time series? Time series are information that are attached with a time. For example, in finance, you have stock market data. If you look at a graph, you have time series data. If you look at weather, and especially weather forecasts, there's data somewhere. And this data is used to make the forecast. But also in your IoT devices. Or for example, your mobile phone. Everywhere is data, it's collected, and this is time series data when a timestamp is attached. So, what is time series data? I've already said it, there's a timestamp. But we have more, of course, we have the measurement. You have one or more values that you want to store, but is it enough? No, of course not. We still need some meta information to know which device we are attaching these values to. So we have a device ID and, for example, some data type like temperature. Is it the outside temperature? Is it the temperature of the device? Is it electricity consumption? Many things that a device could measure that we want to collect. So let's have a look at the time series feature in MongoDB. First of all, let's look at the things we need to know and understand to be able to use this feature, so you don't stumble about weird things in my code when I'm showing it. The time series feature is using connections internally, so it's still used like a connection. So pretty much the handling remains the same if you're familiar with the Mongo database, but the updates also brought new special pipeline operations. One of these I will show you today because it's very useful. And finally, this feature is implemented natively and it has better support and better performance. So the authors say that there is now reduced complexity for developers. Since we are using Spring, maybe we don't really notice that much of an improvement, but we will see. And we will have improved performance. And the improved performance has several dimensions. The queries are more efficient. The disk usage is reduced, so it's using way more space. And this means that the I/O operations are faster now because less is read. And of course, the cache usage is improved as well. So all these benefits also mean that it's cheaper when we are using it in the cloud because the server side needs to calculate less, it needs less memory. One core concept of time series is granularity. We have one premise that data is still always stored in documents. But this granularity shows us how, or you control how the data is stored in a single document. So if you have multiple data entries that appear within minutes after another, then maybe they are all bundled together. This depends on your granularity setting. You have seconds as a default, minutes and hours as an option. And when you choose seconds, then all data entries within 1 hour of a single unique device will be stored in the same document. If you use minutes, if you have a device that sends every few minutes some data entry, then this is stored within 24 hours time span, and for hours 30 days. This allows the database to improve the performance and reduce the size, because everything is bundled instead of having millions of single documents. And when you use it, you should match the unique source entry rate. So if your device sends every 5 minutes, use minutes. If it sends every 2 hours, use hours. Else just use seconds. If you don't know yet, just use the lowest option you can use, because you can only raise this value. So from seconds to minutes, minutes to hours, and not the way back. Then you need to create a new collection and re-import all your data there. And finally, you need to know what buckets are. Here we have a few data points. These data points can be used, for example, to show a graph. So what would we do? We would create buckets of data. So we have time slices. Then we collect all data points and maybe calculate the average of every bucket's value. And this could be a graph that we can show to our customer. But you can also compute different things. You can calculate the minimum, the maximum, grab the first entry, the last entry, the count. The choice is yours. And MongoDB allows a lot of operations. So let's have a look at the code. First of all, let's look at dependencies. What do you need? In a Spring Boot service, you only need the Spring Boot data MongoDB entry point. And here in my code, I'm going to use test containers as a test. So I'm using their MongoDB implementation, which supports the current version of MongoDB. And for unit tests, I'm going to use JUnit Jupyter, because I like new shiny things. So let's have a look at the code. Here we have a small project with a couple of classes, and we are looking at the core entry right now, the class that is storing a measurement. That is pretty much our entity in other databases. One important annotation here is the time series annotation. There we can define the name of the collection, for example, measurements, and specify the field names that contain the time value and the meta information, so the context, which device, etc. And in the end, we specify the granularity that we have just learned about. So as usual, we have an ID in an entity. Here the entity is a string. MongoDB will create string IDs by itself. And here we have the timestamp and the metadata fields annotated per field. I've annotated them so the name doesn't change, because the name is important later on. We will reuse it, but you will see. And
Can you zoom a little bit? Text.
yes. Better?
Thanks.
Wonderful. Okay, so, and finally we have a float value. There could be multiple values that we want to store. This is a measurement that we want to store. This could be a list, that could be multiple values, it can be just a single value like here. So for the timestamp, not all data types are supported. For example, offset datetime doesn't work. I've tried it with converters, but that wasn't picked up by Spring, so I think the compatibility with that isn't there yet. I suggest to use instance, and then just after loading the class, after loading the data from the database, to just convert it to your desired data type. And here for the metadata, we have just in the previous example a device ID and a data type. For the string, I'm using JDK 17 here, so I've used a record for this because it's always read-only when I need it. So we have the measurement, we have the metadata. Now we need a repository. That's pretty much a usual repository that you know from Spring. Here the dependency gives us a Mongo repository where we define our measurement class and string as parameters, and then we have the most simplistic options to create, read and update data. So let's have a look at the test. This test will save data. Here we have a test containers test using the Spring Boot application. Here with the annotation, I'm creating a MongoDB Docker image. It will be booted due to the test containers annotation. Here we have Mongo version 6.02, and this is the newest version there is currently available. And then we set the URL, give it to Spring in the dynamic property registry so it knows where it needs to connect. And finally, we have a test that saves data. Here we are creating 1000 measurements, starting from 1 to 1000. The last entry is today, 6 p.m., and we save the value of 1000, and every hour before we go down with a value. So 999 at 5, etc. So we have 1000 measurements after another, and they are all increasing by 1 every hour. We save it, and after that we will just read all entries in our collection, and we assume if we store 1000 elements, we should read 1000 elements. So let's try it. All entries need to be stored with the same metadata, so they are all connected. So the metadata is pretty much your key to a time series. And the test passed, wonderful, we can save data. So now that we are able to save data, we can start to read data. And one use case you might have, instead of reading all, you only want to read all data of a certain device in a specific interval. So here we have a query that does exactly that. We have the metadata, the lower timestamp and the upper timestamp as boundaries. So this defines our interval. Here in this query, we are defining values that we want the database to query for. So metadata device ID will be set to the parameter of metadata device ID. The data type will be read from metadata as well, and the timestamp uses these two parameters. So let's have a look at the test for this. This test class looks pretty much the same, but we are saving the data, the same data we just saved again, and before each test, and then we here have the test code. Our lower interval boundary is the second, so yesterday, and our upper is today, so we get all entries that we saved for yesterday. A day has 24 hours, so we expect to have stored 24 data entries, since we are saving one entry each hour. So let's run it. And the test passed. This works. Another thing you might want to know is what is the last measurement we saved. To do that, you can write an aggregation. An aggregation is a pipeline with multiple steps that is analyzed by the database, and there are certain improvements in the code if you use certain things. For example, the match can use indexes, and a sort and a limit at the end is optimized as well. So this query should be very, very fast if you're using the correct indexes. So here we have a match operation where we match the metadata's device ID with the value we provide in the given metadata object, the data type just as before. Then we sorted descending by the timestamps, and we limit the result to 1. That will give us the very last entry. And let's try it out. So we are trying to find the last element. And since we are saving values from value 1 to 1000, the last value should be 1000 and the timestamp should be today 6 p.m. because that's the last entry we saved. And it works. Awesome. And finally, I've talked about the buckets before. Now you will see it in action. First, we need to define or select all the data that is relevant to us. So again, we match for the metadata. Then we have our upper and lower boundary for the timestamp that we are comparing. Then we have the bucket operation. This is now set to group by the timestamp, and we are giving boundaries into it. So we want to know what's the lower boundary where everything starts, the first bucket. Where does it start? Where does the first bucket end? Where does the second bucket end? Where does the third bucket end? Etc. So we have a list of dates where these boundaries should be. And with this grouping, we want to know, so in every of these time slices, in every of these buckets, we want to calculate the average value, and we want to save the last value. Finally, we are using a projection to alter how the fields are named when they are returned or before they are returned by the database. The bucket operation saves the timestamp in the ID, in the underscore ID field, and here we are renaming it to start date. We still want the average because we've just calculated it and the last value, and in the end this ID we can drop it, so we set it to 0. Everything we want to keep we set to 1, and finally we sort everything by start date to make sure that we have a sorted list. And so we have a last test for this. We calculate here the average and grab the last value for 2 days. The first day is the 1st of November, so 2 days ago, and the second day is yesterday. So our boundaries are the 1st, the 2nd, and the 3rd of November. Start, middle, and end. So we create our list of boundaries with exactly these timestamps, and we call our aggregation pipeline with this data set where we give the lower and the upper boundary and the list of boundaries. And in the end, we expect to have exactly 2 buckets. The result will be a bucket data DTO. So let's have a look. There are exactly the fields with the return types that we have defined. We have a start date, as we have renamed it in the projection earlier. Then we have an average and the last value. MongoDB calculates values with the accuracy of a double value. So I want to use the double value here, so I'm not losing any accuracy of the average. I'm just using the last form because maybe I'm not sure what I've saved before, although we have saved floats. Then when we have the buckets, we know there should be 2 buckets. This first start date should equal to the start that we have specified. Then we have an average value, a last value that is higher, and then we have the second bucket. Because our values are all increasing, the average and the last will be higher as well. And our start date is now the middle boundary. So let's test it, try it out. This is the last thing in the code that we are going to execute. It takes a moment, and yes, it works. So this is an example how things are used and created, but there are a few issues that I encountered. For example, usually I would use annotations to create a collection and also specify an index. But this didn't work. Spring didn't create the correct type of collection when I used the index annotation. And so I've created the collection, the time series collection, via the Mongo template. And after that was created, I can then go ahead and create the correct index. So our queries and aggregations are really fast. Else they will be really, really slow. Because column scan on time series data will be really slow. Because you have to expect that there is just a lot of data. So at first we create the connection, we ensure that it exists, and after that we create the index. With the Mongo template, it's pretty easy. You just, if it's not exists, we just create the collection. Here in the create collection call, the annotation is correctly processed, and indeed it will be created as a time series collection. And the index here can be called or created using the index operation on the class we had earlier, on the measurement class. And there we ensure that an index exists. And here we define the index using metadata.deviceID and metadata.datatype. It's important to use the fields. You can't just use metadata because then it won't be read. Or it will be read, but it will still be terribly slow. So I ran into that problem, so don't do that problem. And finally, we have the timestamp. So we have all fields that we are querying for, that we are looking for. So everything will be nice and fast. In the tests, these collections and indexes have already been used. So let's head back to our presentation. Now, the tips and pitfalls that I've encountered while using it. The best tip I can give you is use MongoDB Compass. It's an excellent tool by the authors of MongoDB. There you can test your queries, test your aggregations, test out the other operators. You can explore the features that there are. You can check which index is used. You can verify the time it takes for some queries, and it's a great tool. Try it out. And finally, we have pitfalls, the things I did wrong practically. So Spring Data MongoDB isn't feature complete yet. For example, there's an expire after seconds property that can be really useful if you don't want to delete directly and just want to move it somewhere else in another collection and then delete it like 2 weeks later, because maybe you need this data. Here in the current version, you can't specify it. Also, since I've created the wrong type of collection by accident using the annotations, and at the customer, we also had that in production, so that wasn't great. So ideally, I would like to have a test that just checks if the collection is really a time series collection. So I don't have to check it somewhere else in another tool. Automated tests are awesome. And finally, the index creation that caused my issue in the first place, which is enabled by the property you can see there, that creates a collection, but not a time series collection. So it's creating the wrong type. And that's a problem I ran into. I hope this will be fixed. And finally, the index must use the actual fields of the meta field. You can't just use meta field and hope for the best. That didn't work out. You have to use metadata.deviceID. Although the index is really, really large if you use metadata and index on metadata. For some weird reason, this also worked only on the not time series collection, so on the default collection. There I could use metadata. On the time series collection, metadata didn't work itself as a field. There I had to use the proper fields, the actual fields, so the device ID and the data type. So let's talk about what I've just shown you. Let's recapitulate. I've talked about time series. I've talked about the granularity as a core aspect. And then I've showed you the integration in Spring. There we had the time series definition. We had collection and index creation via the Mongo template bean. We had the Mongo repository along with its queries and aggregations that you define there. And a special operator I've showed you is the bucket that is really, really useful. And finally, I've shown you the pitfalls and the useful information, the useful learnings I had. So, thank you for your attention. You can find the slides online on the URL or just make a photo of the slides, scan it, or send me a message on Twitter or find my code on GitHub. Thank you for your attention. If you have questions, now is the time. Write it in the live stream chat. Tell me here in person.
Yep.
I'm here and I'm trying to answer them.
Thank you, Christoph. Very nice talk. Thanks for keeping the time series in in the eye. If there are any questions from here, please ask them. If you would like to repeat the question if they are from here, so everybody at home can understand it also. Any questions from you guys?
Just one more use case, maybe?
Yeah.
One more use case.
One more use case.
So one use case, for example, would be temperature or consumption of things. For example, if you have a heating system in your basement that generates hot water, in future they will probably be connected to the internet and you will be able to follow your consumption and the temperatures online on your mobile device. That would be something. Or in finance, stock data, for example. Pretty much everything that has a timestamp and a measurement, some values attached to the timestamp. All that is time series data, all that can be tracked, all that has a use case of this.
How is the performance compared to other databases and storing timestamps just in regular other databases such as Oracle or whatever?
I've not used the time series feature in other databases yet. My customer used TimescaleDB and I think it was comparable, at least for the amount of data they had. But they weren't too happy about it. They are afraid about scaling and they were using MongoDB already. So they have a few experts of MongoDB in-house. So they thought, let's switch over for the new features, try it out, and in the end we will see if they need to migrate or just keep everything separated. So there are multiple databases. I don't know yet the differences. I only know this and I'm pretty much only a beginner. I've used it this year and well, the project is in production for 2 weeks only, so most of these pitfalls were discovered by me in the last 2 weeks. So it's a just-in-time talking.
Yeah. So no comparison with other databases. That's your answer, in fact.
Yes.
What is the comparison? Because there was a claim about the size of the data.
Oh yes, yes. Since I've accidentally created the wrong collection type, I've actually took a measurement of that. Can you switch the camera? and I've prepared a slide for that. Here we have two measurements. The top one is the classical collection, and the bottom one is a time series data. There are stored 4 million measurements, and the classical one is taking up about 2 gigabytes of size. It's reporting a little bit more here, 2.43 gigabytes, but the indexes are quite large because we had a few more indexes because the performance wasn't great, because in the end I've created the wrong indexes when I've compared it. So it's about 2 gigabytes to 370 megabytes only. So
That's a good.
that's like a 75% reduction. The authors of the MongoDB claim that they have like up to 97% improvement, but that is compared to the uncompressed size, as far as I understood. So I
But
assume 75% is something you can really think about and work with. And in the query times, I think they are very acceptable. Right now it's like 100 milliseconds query time, I believe. Maybe there are ways to optimize it, but it's in production, but there was no app release yet. So the new users aren't using it on a big scale yet. So it's all just in time. It will come in the coming weeks, and maybe I know more. So ask me in a few weeks.
Yeah.
Maybe
I
can
got
tell you
a last question about maybe a couple of weeks, maybe a couple of months, because you said there were some things missing in Spring Data.
Yes.
Do you have any idea, or did you hear anything or any information about when these features or these missing features, in fact, would be added?
Last week I looked into the Spring Data repository on GitHub, and there was a pull request for the seconds that automatically will delete your data. So the seconds to expire, I don't remember the correct name right now. It was on the slide before. But the other features, I don't think so. I haven't seen a pull request for that yet, but it's open source. We all can contribute if we really need that feature. Everything is community driven, so just go ahead, implement it yourself if you think you are capable of doing that. And if not, I've presented you a way that still works right now, but you can improve it over time.
Maybe it's an idea for you, right?
Yes. Well, I'm using it, so
Okay.
probably I will look into it.
Thanks. Any other questions? Here I'm taking a peek at the live chat. No questions there. Also take a peek at the watch. So thanks a lot, Christoph. And next one on is Jens.
Thanks a lot.
Yeah, while the laptop is being connected and Jens is coming forward, a short introduction. Second talk for today. Jens, experienced software developer at OpenValue. You might know him. This is not his maiden meetup talk. He had a previous talk on Greenmail. Maybe you've seen it, maybe you were there. If not, check again the YouTube channel, because you can find the recordings there. And you will see more of him tonight. But on Javaland he will also have a talk. So he's going to become very famous, I think.
We'll see.
And this evening a talk on AWS lambdas and how to test them. And he is preparing, but it looks really good already. So I will talk some more, tell him about everything. Well, his little sister is here present, so it's also an extra motivation for him to to take it away very well. And I would say, please enjoy the talk of Jens. if you have any questions, save them for the end. And at home, obviously, if you have questions, just post them in the live chat. Jens, the floor is yours.
Yeah, thank you for the nice introduction. So this talk is about the local testing of AWS serverless lambda functions, and they're officially called that way, but in the talk I'll just refer to them as lambdas, because it's just a lot simpler. So how did I come up with this topic? I've been working in, sorry, the mouse, need over here. I've been working in microservice projects before, and you got a clear test strategy defined in there. And when I came to a cloud project for the first time, I've been missing this actually. And I did some investigation, and actually we're not the only one having that gap. You can't really find a lot of information there how to test your lambdas. So I think manual deploying and testing is not an option. It just slows you down. And testing is about getting feedback and getting it fast. So I want to do it locally, and because it just reduces my feedback cycles. And that's also why we're going to focus on automatic testing in this talk. So as I said, I've been working in microservice projects before. Sorry? So I applied the testing strategy on lambdas, and it actually turned out quite well. And that's why I'm going to present my results today. So a few slides about me. Thanks for the introduction, Garrett. But I still talk about some words. I'm a software engineer working for OpenValue in Düsseldorf. Even though it sounds like I'm totally into testing, it's just partially true. I like when my software is well tested. So when I'm doing refactorings or stuff like this, it just gives me a sense of security, and I like this. So I already said a little about what we're going to do. So first part is going to be the testing of microservices. We'll have a look into that, how this is done. Afterwards, I'll explain what lambdas are and give a little comparison between lambdas and classical microservices. And we'll actually see that lambdas are also kind of a microservices and may be used or can actually be used in a microservice architecture. Then we'll apply the testing strategy of microservices to lambdas, and I'll introduce a little example application where we do the testing. So first, the testing of microservices. Here's an example of a small microservice, and it's implied that the service is structured using the ports and adapter pattern, which means all external dependencies are connected to the service layer through an adapter. This makes it easy to test the service layer independently, also the domain logic. One part is the REST adapter, and it declares the endpoints of the service and defines how the service can be called and which values are actually returned. So the external adapters are just an example. So there may be a database adapter, which is used to read and write values to database. And we might actually want to connect to an external service, which gives us some information which we need to calculate something. So let's see how we structure our code to test this. We start with the smallest kind of test we know. It's unit testing. And depending on the framework we use, we're able to test the REST adapter as a unit test. Oh, come on. There it is. So depends on the framework. So maybe you're just able to test it as an integration test. It's also fine, but you'll get it, I think. So also the same applies to the domain and the service layer. They are independently, they have no external connections. You can just mock the adapters and have a nice and clean unit test. So what follows up are the integration tests. And integration tests are tests between external components, and I want to test the integration of my service to this external component. And in this example, I got a database as an external component and an external service. For example, the database may be tested using test containers or in a memory store, and the external service might be mocked through something like via mock HTTP server or a simple stub. Yes. So next step, it's actually the biggest step in microservices, the component test, and it's the test where we test the service as a whole. There we also need to replace, like similar to the integration tests, our external dependencies. Yes, and that's it. So if we sum it up, we got a lot of nice colorful boxes in there, and we can see that all the elements are actually tested. Whenever it's possible, things are tested in isolation. All external dependencies are integration tested, and we start up the component, fire request on it in a component test. So we test the whole thing. And what we can see here is the test pyramid in action. So we probably get like a few elements which are unit tested, which produce multiple unit tests. There are two different external services, so two integration tests. And we got one component, so there's one component test. So if we structure the tests by their amount, we'll get something like this. And yeah, just for the sake of completeness, I also added end-to-end tests and manual testing. Due to the shortness of the task, of the presentation, I'll not get into end-to-end testing because it can get really complex in the microservice environment. It's just simply our scope for this talk. And what we actually want to do is reduce manual testing with our setup. There's still like possibilities to, and actually use cases where it makes sense to test your lambdas manually, but also due to the time, I'll skip it for now. Which brings us to what are lambdas actually. Lambdas are very small and simple functions that get executed when they're called. And we don't even need a web server to run them. AWS does it for us. We just have to implement an interface, implement an event handling method, and we can, just work on the inputs and outputs we get. Then we have to zip it. In our case, when we're working with Java, we create a jar file, which is just another thing as a zip file, and upload it to AWS. There are also other deployment methods which involve YAML files and the handling of it. But we want to do it locally, so deployment is not that a big thing for us. Next thing to know, lambdas are triggered by events. So they can be part of an event-driven architecture if you want to. And you can either define custom events, or you can use predefined AWS-specific events, like a file upload to S3, which is the storage solution of AWS. One nice thing about lambdas is the automatic scaling, and which means lambda functions only run when you need it. So when a lambda is called, it might get started because there's been no load before, and when there's no load after, it might get shut down again. And this means when you're using lambdas in your architecture, you only pay what you consume. And actually a nice side effect of it is that we cannot have any state in memory. So we have to think about that. Each lambda we have and with that we start might get shut down in the future. So we got the lambdas, and let's compare lambdas to classic microservices. In classic microservices, you can configure your web server. You don't have to when you're using embedded web servers, for example. But as soon as you want to get to, for example, for performance optimizations or things like this, you actually want to do this. One big difference in lambdas and microservices is that lambdas can only have one endpoint. In microservices, it's actually common to have multiple ones, and most projects I've been in, that was actually the case. And yeah, when having microservices, you usually do the scaling yourself. So you would usually deploy it to a Kubernetes cluster and define how the scaling works, what are the parameters for scaling, stuff like this. Things like statefulness are possible in microservices. When Lambda is a lot more difficult. And microservices are, so it's more my experience. So in most projects I've been, microservices tend to grow over time. So at some point they might be micro and then they go like macro or big services, who knows. With lambdas this can't happen because they're like constrained through the framework. And yeah, to sum it up, lambdas are quite similar to microservices, but physically constrained in their size. And a lot of things we have to do in microservices, we actually get this from the AWS framework. So now that we've seen that lambdas and microservices are quite equal, or that lambdas can actually be microservices in microservice architecture, the testing should also be the same, or at least quite similar. And we can use the same tools. And yeah, in my opinion, the most valuable tool we have for testing is dependency injection, as it actually it actually forces us to create testable code. And in a small service like Lambda, we don't even need a dependency injection framework. We can just do it manually. I also gave some examples like test containers and wiremock, and there might be multiple else, which we use for stubbing and mocking external services. And we also can use this in a Lambda environment. The only thing that's difficult for us is testing AWS-specific tools. Like, what if we want to connect to something like the simple storage solution S3 from AWS? Yeah, and there's like a new kid on the block, a new tool, local stack, and yeah, it actually aims to start a local AWS environment for you, which you can use for local testing. It's just perfect for testing purposes. So now that we've seen the tools, I'm going to explain what use case we have. We got an entity, which might be user or another service, and the user has an image. And I took just our company logo because for a compliance reason, I just wanted to make sure that the cat picture I had before was not copyrighted. That's a lot easier. So the user has an image and he wants to make a thumbnail out of it. So he uploads the picture to the file storage, and then he tells our Lambda that he wants a thumbnail out of it. So he calls it and gives the Lambda the location of where to find the image. The Lambda then retrieves the image, shrinks it, and puts it back on S3, and responds to the user where to find the image. The user can then just exit it, and he has a thumbnail for itself. So let's check how we're going to do it in code. So as I said, you have to implement an event handler in Lambdas. And this is the entry point for the Lambda. This is the method that gets called when we fire an event at the Lambda. So we have to implement the request handler interface. Yeah, highlighting works now. And the handle request method. And this method is executed as soon as the Lambda is called. And we're free to define inputs and output for the method. And here we just use simple POJOs to transmit the location of the file in S3. And actually, yeah, For the output, it's the same, but for the thumbnail. So I usually, because this is AWS logic, I try to keep this method as small as possible. I want to test my business logic in isolation. It's what we saw in the microservices. So my domain logic, keep it apart from the rest, test it as unit tests, and yeah, test this in another way. Well, we'll see later. The only exception that we got here is the dependency injection going on in the constructor. Here we define all our services we need to actually process the image. And you can see this is actually manual dependency injection, because we just create services, inject them in the event handling service, and yeah, we're ready to go. Yes, and let's check how the input and the output looks. I already explained, it's just simple POJOs. The input is the bucket and the key of the image, and the output is the bucket and the key of the thumbnail. And we're also returning like a direct link to the file, which allows like easier handling. We can download it right away, whatever we want. I can't use records here actually, because AWS doesn't support JDK 17 yet. So I still have to stick with JDK 11. We saw that the event handling service was called. So let's look at this next. This is what the lambda calls after it was called. And what it does, it retrieves a value from S3, from the storage server, resizes it with our image service, and just uploads it again to the storage server. And yeah, that's it. I left out some code because there's some nasty transformation between the image, input streams, output streams, and yeah, that's not like beautiful stuff in Java. So I just don't want to show it. There's source code online. It's on the back of the slides. So if you want to check it out, you can do it. So let's get back to the services. We're using the S3 service and an image service over here. And we use the S3 service to upload and download files. And yeah, that's all it does. And the image service is what we use to create to shrink files. And actually, we don't care about the implementation because we just want to test them. So that's what we're going to do now. Go duplicate and go into how it works, because I'm using IntelliJ, the Windows subsystem for Linux. And it's still kind of buggy, but better than developing on Windows. So this is the test for the image service, and all we do here is use an image, resize it with our service, and check that the dimensions are less or equal than the ones we predefined. And yeah, to show it and to test it manually for this presentation, I also outputted it to the target folder. So let's just run it and check how it looks in the end. So it's unit test, it's fast, there's no external dependencies which we have to start up. So yeah, it's the tests I prefer, small and fast. Let's check. This was the actual image, 1500 by 1500 pixels, and the resulting image looks like this, 300 by 300. And yeah, it's shrinked, it's the maximum dimension we predefined, so this test seems to work. Like one big chunk of our logic in our lambda is actually tested now. Let's go with the S3 service. As we remember, the S3 service is an external dependency. It's something from AWS that we have to call. Like this. My screen size is a little small, so I'll put this one away. So S3 is an external dependency, so we have to use a stub or a mock or something to actually, test our integration with it. And for this, we use test containers. Test containers fires up a Docker container and actually handles all the stuff we want to do with it. So before the test, it starts it. After the test, it stops it. It removes the container. All the life cycle of a container is managed by test containers. And we tell the local stack test container to start up an S3 service, because that's our integration we want to connect against. For testing purposes, I implement my own S3 client here, because we want to do some test setup. So if you want to download a file, there has to be file online. And I don't want to use my existing logic to depend on itself. So like I get like a cyclic dependency when testing. So I do like uploading file and receiving a file with another client. So I'm not dependent on my service implementation. Next part is the S3 service. Actually, that's what we want to test. And usually it would connect against the AWS cloud. But we want to tell it to connect to local stack or local, let's call it cloud. We're giving it an endpoint override. So it will now connect to our local instance. So let's check one interesting test that doesn't have some error case involved, and it's like the receiving of an object. If you want to receive an object and download it, we have to create a bucket and a file first, and actually create it in the S3 instance. Then we use our service to retrieve it, and we assert that the file is equal and the content in it actually as well. So let's run it. It should run a little slower than the unit test, because we have to start up our external dependency, which is a Docker container. But still not that slow, maybe just 5 seconds or something. And there it is. We actually proved that our client can download files from S3. Let's check if it also can upload files. So we create a bucket to have something to store files in, and create a simple file as a file stream and upload it using our S3 service. And in the end we get in the end we can download the file and actually check again that the file content is equal. So let's run it once again. Also, test containers will start up the S3 instance here again. And we actually showed that we can put objects onto the Amazon cloud. So I also created a component test, which is one of the bigger tests we got here. And it's also a lot more complex. It's also test containers test, but we're not only using the S3 instance, we actually have to start up the lambda. And starting up lambda is something that usually can be done in the AWS cloud, but we're going to do it locally. So we have to tell local stack that we also want to create a lambda. And the lambda and the storage solution want to talk to each other. So we have to create a network on which they can talk. So we have to create a shared network with a network alias for local stack. To actually have a name so they can communicate. So when we start the container now, we got S3 running, but we have no lambda yet. We actually have to create it. And we can do this using the AWS SDK. We have to define our environment variables over here, the runtime, and actually the method we want to execute when the lambda is called. Then we define the zip file and the location of the zip file. And this is actually the tricky part, because what we're going to test here is not only the code, but the jar file. And this means this test has to be executed in another stage of the Maven lifecycle. Because usually in the test stage, there is no jar file. The package stage is later. So we can actually use, I think it's the Surefire plugin and some nice renaming of the test to make sure that the test runs in the verify stage after the package stage. So that makes sure that there actually is a jar file we can upload and which we can fire requests to add. So let's have a look at the test. We create a bucket and we upload a file, like we've seen in this example on the slides. And then we invoke the lambda, and we invoke it with the key, with the bucket and the key where to find the image. And this might look like this, because lambdas usually get called with the JSON syntax, like any REST service, or like usual REST services. So after calling it this way, we expect that that we get an OK response, which is the HTTP status code 200, and we also assume that the image we get back is shrinked. So let's run it. Should be a little longer than the test we had before because there's two containers starting up, but we should see some nice log messages in there where we see how the buckets are created, the lambda is started, it's running, it says it's running here, and the test passed. Yeah, we should see somewhere over here that there is a response, status code 200, but there's, actually the response is coming back as a byte array, so it has to be parsed so we can really see how it's looking in there. And we tested it, but does it actually run in production? So let's check this. I deployed the lambda. This again. Somehow this is always kind of weird. I deployed the lambda as a jar file to the AWS cloud. Oh, sorry, it might be a little small, right? And I got an example JSON in here, which looks kind of similar to the one we had in the component test. And I can just, and it refers to a file in a bucket. Oh, forgot to clean up the thumbnail image over here. But yeah, we'll see that it changes. So I uploaded an image over here. We refer to it, tell the lambda to shrink it. Let's fire this request at the lambda and see what the result actually is. This may take a few seconds because the lambda is unused, and lambdas usually have like a cold start time because it has to start up. When it's running, it's able to process the request faster. I didn't use it like in the past 1 hour, so it takes maybe a few seconds. So we get the response we defined, a bucket, a key, and a link to the file. Looks quite similar to the POJO we defined, just in the JSON syntax. And if we refresh it over here, this date should actually change. Oh yeah, it's 20:08. Let's compare the clock. It looks like it happened like just a few seconds ago. So what we did was verify. We tested our lambda. Come on, close. So we tested our lambda. We actually proved that it's also running in the AWS cloud. And I hope you all have now an overview how you are able to test your lambdas. And if you want to see a little more, the slides can be found here. The code is also in the GitHub repo. And if you want to dive a little more into the testing of microservices, there's like a really great article of Martin Fowler about it. yeah, very detailed. I stole a lot from him. And yeah, thank you very much. And you're free to ask question now. Just if you don't come up with a question later, just write me an email. I'll answer it.
Thanks, Jens. Well, time for questions. If any questions come here, please repeat it for the people at home.
Sure.
I'll check the chat. Well, there's one more comment in the chat. It was regarding the statefulness of the lambdas.
Yeah.
And the suggestion was to theoretically store the state in a S3.
Totally possible. Yeah,
but possibly not a good idea.
Yeah.
And the one writing in the chat is actually here. Do you want to add something to it, or just a smile? Okay. Any other questions maybe from here?
Just one. In the beginning you said that traditional microservices tend to have multiple endpoints. I didn't get that exactly.
So like on the Lambda, you have...
The question maybe.
yeah. So the question was that traditional microservices tend to have multiple endpoints. And so if you have, for example, a microservice which does user management, might have an endpoint for creating a user, updating a user, and deleting a user. In the Lambda, you can't have that. You have to have 3 different Lambdas for each endpoint.
Okay. Thank you.
Welcome.
Yeah, you told us something about AWS lambdas, and we know that there are some other cloud platforms, Azure, Google Cloud, and Azure has Azure Functions, I think, and Google Cloud has Google Cloud Functions. Can you use the same approach for that, or the differences?
I would say partly. Like you can do like the unit testing stuff. You can structure your code in the Lambda. You can always do unit testing because you have no external dependencies. But concerning like the external dependencies to the cloud itself, might be kind of difficult because local stack's only working for AWS.
Okay.
And I don't think there's like similar tools in the Azure and Google world, but I'm not really sure about it. So
Okay.
don't hang it. It's wrong.
No, we won't. Okay, I'll just look at the chat if there's anything coming in. If not, then it's time for a short bio break at home and here. You can take a short break, take something to drink maybe, and I would suggest that we start again at 20:25. So a bit more than 10 minutes break, and then we already are excited about the talk of Sebastian. And for now, Jens, thanks a lot.
Thank you too.
Great. Yeah. Welcome back. We had a short break. It was, I think, too short, but for those here present afterwards, we have plenty of time to talk further and enjoy everything that's there. But now, last but not least for today, Sebastian with his talk on test approaches. And big question, I think, as in on many minds of many developers, am I testing the right way? Sebastian is also not quite new also on this stage. He did some talk before. It was also about testing. You should think, hey, he's totally into testing, but I think he's a real all-rounder. And since testing is very important, I think this is a topic that, that's logical also for him to cover. Without further ado, the floor is yours, Sebastian.
Thank you, Garrett, very much for the short introduction, and welcome everybody here for the next talk, Am I Testing the Right Way? So when it comes to unit testing, have you ever wondered, am I doing this thing right? Well, I have, and today I want to go through 2 unit testing approaches in detail with you. And maybe we can find an answer to the question on how to write unit tests, or at least better unit tests. So again, some words about me. I'm Sebastian Konieczek, employee at OpenValue Düsseldorf, a dedicated software developer, Java enthusiast. I at least try to be a clean coder, and I am a naming enthusiast because I think names matter, at least in software development. Here a short introduction of my partner in crime for this talk. I had a lot of discussions with him about how and why should we do a specific kind of testing, and he also supported me in creating the example for this talk, and also helped me writing a blog post about this topic. He is a senior software engineer at Zalando, passionate about testing and code quality, interested in programming languages and implementations, and he's a coffee enthusiast because coffee matters, at least in software development. So let's start this talk with a short question. Who of you writes unit tests? Component tests? Anyone? Integration? End to end? Not so many, but I guess we all agree on writing tests for our software because, quality matters and we don't want to get mess into production. And for our case today, for our scenario, we consider all of these different levels of granularity unit tests. Well, at least unit tests, of course, component tests, and integration tests to some extent. So all tests that you can literally test in your own code base without needing some extras and extents. What this talk is not about is E2E tests. You may ask yourself, why do he also talks about component and integration tests? I thought this is all about unit testing. Well, let's have a look at what a unit is then. Let's start with a short introduction, with a short definition here. So a unit could be a method, or a class, or even a cohesive group of classes that together compose a feature. Or to say it with a quote, oh well, that's a lot of text and probably too long to read. So let me summarize this for you. I need to use this one, sorry. So in object-oriented design, we tend to create a class as a unit. In procedural or functional approaches, you might consider a function a single unit. But in the end, it's really a situational thing, and the team should decide of what makes sense to be a unit in their specific scenario or application. And although I start with the unit being a class, I often end up with a bunch of closely related classes that compose together a single unit. But in the end, however you define it, it doesn't really matter. Does anyone have an idea who said that? Here, it was Martin Fowler. So I guess everything is clear now, isn't it? So what is a unit? I think it's kind of vague. And for our scenario, we just consider all of these levels of granularity unit tests. Now that we have this thing set up, let's have a look at our example. For our example, we created a simple calculator app. This calculator app has a very well-defined and clear public interface, and it looks like this. It gets a mathematical expression as an input and returns the result as a double value. Let us see what an expression looks like. For an example, the expression 10 plus 20 minus 3 plus 4 is represented as the expression tree below. The tree is evaluated bottom up, so the calculator at first evaluates the plus expressions. This part of the tree represents the operation 10 plus 20. The right side represents the plus expression 3 plus 4. And finally, it evaluates the minus expression. It utilizes the results of the plus expression for that. So this is, in this case, 10 plus 20, so 30, minus 3 plus 4, 7. And in the end, the calculator should yield the result 23. So the expression is a tree of operations, and each node is one of the operations plus, minus, multiply, and divide. And the leaves of the tree are numerical values. So if you are familiar with interpreters, you can think of the calculator as some sort of abstract syntax tree interpreter for algorithmic expressions. So how does this look in code? Well, we have this simple main class here with a very simple main method. And what does this code do? At first, we instantiate our calculator, of course. And next, we create our minuend and subtrahend nodes, each represented by a plus expression. Now, we can define our final input expression. We utilize a minus expression with the previously created minuend and subtract expression. At last, we use our calculator to evaluate our input expression and finally print the result. Now let's have a closer look at the implementation details. We'll now give you a short overview of all the components we implemented to make our calculator work. Each operator that you have seen implements an expression interface. It looks like this. The expression interface is a sealed interface, so it only allows for specific implementations that we mentioned here. So the plus, the minus, multiply, and the divide expression, and also a value expression. For every expression, there also exists an expression handler that is responsible for evaluating the result of a specific expression. And every expression handler needs to implement the expression handler interface. And the expression handler interface looks like this. Again, we have a sealed interface, and it also gets the type of the expression. And it only allows for these specific implementations. So every expression has a respective expression handler. Also, this interface has an evaluate method that is responsible to evaluate the result of the specific expression and does the heavy lifting. How does an implementation of these interfaces look like? Let's have a look at the code that handles divisions to get a grasp on it. At first, we have the division expression. It looks like this. The division expression is a simple record that gets the dividend and the divisor as an input or as fields. And it implements, of course, the expression interface. The respective divide handler, expression handler, looks like this. It implements, of course, the expression handler interface that is typed to the divide expression. And, of course, it implements the evaluate contract of the expression handler interface. And it gets the calculator and the divide expression as input. We now, as we do not exactly know what kind of expression the dividend and the divisor expression of the divide operation is, we utilize the calculator here to evaluate the result of these, because we do not want to handle all the specific types in our divide handler ourselves. So we just call the calculator here to get the value of the divisor. Then we check it for 0 to avoid or to give some meaningful exception in case there would be a division by 0. And finally, we also utilize the calculator to get the value of the dividend expression and then simply perform the division. So how do we express numbers in this example? For this, we have the value expression. Again, it is a simple record that implements the expression interface, but the value only has one field, and this is the value. As I said before, every expression has a respective expression handler, and so does the value expression. So here is the value handler. The value handler simply returns the value of the expression. So you can speak of it as a constant expression that only gives us back the numbers. So, putting it all together, in our calculator class, let's go through it very quickly, because there's not so much interesting stuff in here. We just get the expression handler for the input expression, and we just call evaluate, and then we return. You might ask yourself, where does this expression handler provider come from now? So, well, this is just a small helper class that abstracts away all the code that matches an input expression to the respective expression handler. It would just be very verbose here in this code, and to keep it simple and understandable, we just put it in a helper class. If you're interested in what the expression handler provider can do, at the end there's a link to the GitHub repo, and you can just take a look yourself and investigate. So, how do we test our calculator? Let us take a look at two contrary approaches, the fine-grained and the coarse-grained style. The fine-grained style focuses on single classes. So it sees a single class as or defines a single class as a unit. To ensure that it tests all components of a software or of an application separately, and to ensure the desired functionality, it also tests the component interaction. In the fine-grained style, we use test doubles for all collaborators on a class level. We will see that in action later. And there are some parallels to the Mockest or London School of Test-Driven Development and Martin Fowler's definition of solitary unit tests. The coarse-grained style, in contrast, tests a cluster or a cohesive cluster of cohesive objects or classes that together compose a feature as a unit. This unit is then only tested via its public interface, and it only uses test doubles for external collaborators. And you can draw some parallels to the classic or Detroit school of test-driven development and Martin Fowler's definition of sociable unit tests. So now let's start with the fine-grained style. What component should we test? Well, I guess we must not test the interfaces, right? Because they do not contain any valuable code. And probably you would agree with me that we do not need to test the record classes as well, right? So, well, then this is all that's left. So we need to test all of these single components. Okay, we will skip this one today because of we do not have enough time to go through it. But we will have a look at the rest of the classes, and of course the test for this class is available at the GitHub project. As I said, you get the link at the end. So let us start with the handler test, specifically the plus handler test. So before we go through the test, let us take a look at the plus expression. Now this looks very similar to the divide expression from our example before, but instead of the dividend and in divisor, the plus expression gets an origin and an addend as its fields. So the interface of the plus handler itself looks like this. It takes the calculator and the plus expression. Again, very similar to the divide handler, but instead it does not get a divide but a plus expression. Now let's look at how to test this plus handler. So this is some pill to swallow, so let us go through it step by step. At first, we define our plus handler as a field variable and create an instance of it right away. And we also define the calculator as a field. In our before each step, we create a mock object for the calculator class, because we do not want to test the behavior of the calculator, but only of the plus handler. Our test is a parameterized test with the given origin, the addend, and the expected result as an input. And we have some simple tests here defined, like 2 plus 3 is 5, or minus 3 plus 1 is minus 2. So in our text, we then create also mock expression, mock objects for the origin and the addend expression, because as I said before, we do not want to test the behavior of these expressions or the respective expression handlers. But for our test, we do not care what kind of expressions these even are. Next, we define that when our mock calculator object is called with the origin and the added expression, they return the respective value from the example, from the input. Finally, we can create our plus expression that we need as an input for the plus handler, and then can call the evaluate method of the plus handler. And yeah, at the end we can assert that the result is somewhat close to the expected result. As we handle with doubles here, I added an offset at the end, so yeah, it won't fail when there is some floating point inaccuracy. So now let's have a look at the calculator. Besides the expression and the expression handler, which the calculator obviously acts with, it also acts as it also has the expression handler provider as a collaborator. Just a short remark for the test we will go through in a minute. So a quick recap of the calculator interface. We have the expression as an input and the result as a double value as an output. So now let's look at the test for this class. Again, we will go through it step by step. We create a field variable for the calculator itself and the expression handler provider. But why do we not instantiate the calculator right away? This is because it gets the expression handler provider through constructor injection. So in our before block, we create a mock object for the expression handler provider and now can instantiate our calculator object with the expression handler provider mock. In our test case then, we define some random expected result of like 1.2. And now we create mock objects for the expression handler and for the calculation expression. Here we define that the expression handler provider should provide our expression handler mock when our input calculation expression will be handed over as an argument to the provider method. And we also define that the expression handler shall return our expected result when it gets evaluated with our input calculation expression. Again, to really emphasize this part of this testing strategy, we are not interested in testing any other functionality than the functionality of the calculator. So we want to mock all collaborators away so we can focus purely on the function of this class. And finally, we just call the calculate method of the calculator and assert that the result is equal to the expected result. With this approach, we now can see that this calculator class obviously has no inherent logic or business logic. It is just a compound class. So this test helps us see like in what way the class under test behaves. So let's have a short conclusion about the fine-grained style. At first, some advantages. It focuses on the exact behavior of the class under test, so you don't get distracted by any other collaborators. Like you don't need to think about, well, what is the contract of the expression handler provider, for example. We just mock it away. We are not interested in it, how this works, or like for the, as we have seen, as in the plus handler test, we don't need to know, or we are not interested in what kind of expression we get and how it is evaluated. We just can focus on the behavior of the specific class under test. Due to this focus, it helps you to find the right level of abstraction and class design. So it can really help you with this, because if you like when writing a test have a lot of collaborators or confusing test data or something like this, this can be a sign that your class design or your level of abstraction is somewhat messed up. It also helps to keep your test code small and straightforward. Again, as you focus on the exact behavior of a single class, you don't need to have like or consider a lot of mock data or a lot of input, output. So it is really small and straightforward test code. And because it is small and straightforward, it is also easy to understand. It can also help you to understand the interaction of the collaborators on a class level. But it's not all sunshine in this approach. We also have some disadvantages here. One disadvantage is you might be forced or tempted to open up your API. Because as we saw before, the expression and the expression handler interfaces, they were sealed. But in the tests, we created mock objects for the expression and expression handler. And this is not possible if the classes are sealed. So if we want to do that, we need to unseal the classes. And this opens up our API, which is in most cases not a very good thing. You might also be tempted to add some test-only code to get your class in some specific state. This again is a very bad practice and it poisons your business logic. And the test and the implementation of the code, they are really tightly coupled. And if you refactor your code, you're most likely forced to also rewrite your tests, or at least to adjust them to the new structure of your classes. And another disadvantage is that there might be a lot of test classes at the end. So you might not have a good overview of all the test classes and how these classes are all tied together. So that's about the fine-grained style. Let's have a look at the coarse-grained style. So what component should we test here? As we said before, for the coarse-grained style, we only test the public interface. So in this case, we only need to test the calculator. All the rest we do not need to consider. So how do we test the calculator in the coarse-grained approach? At first, we create our calculator instance as a field variable, and we instantiate it right away. Note that we are not using a mock of the expression handler provider here, but the real-world implementation. Because we use the public interface, we just can provide like the real object. We don't need mock objects here. Our test is a parameterized test again. It gets the expression, the input expression, and the expected result as an argument. And we have a lot of test cases defined here. So a lot of cases for like every expression we want to test, and some cases for every expression. So there's many more test cases here than in the finer grained style for a single handler. Because with the coarse grained style, we obviously need to test all the cases through the public interface. So the test then is rather simple. So we just call the calculate method of the calculator, hand over the expression, and assert that the result is close to the expected result given in the test method. So, and of course, there's a division by zero test here. This division by zero test would be part of the division handler test in the fine-grained style, but as we only have one test here for the public interface, we need to, one test class here for the public interface, we need to test it here. So that's it. Let's draw some conclusion on the coarse-grained style. At first, again, to the advantages. It helps you to define a clear and well-defined public interface, because if you realize maybe you have a lot of external collaborators or confusing input data, confusing output data, it can give you a hint that your public interface is probably not very well designed, or that your component does a lot more than it should do. And it also helps you with information hiding, because this style of testing allows you to keep your API as closed as possible. You don't need to unseal any interfaces. You can have a lot of like private or protected classes, and nobody ever cares because you don't need to create mocks of these classes. And also, it allows for easier refactoring of implementation details, because if you only test through a public interface, you can refactor all the implementation details as you want, as long as the the tests through the public interface succeed and the public interface stays stable, you're good to go. But there are also some downsides in this approach, and one is that because you only focus on the public interface and you can like do in the implementation whatever you want, sometimes the quality of the internal design of a module or the quality of the internal design of the module is not that is not in the focus of this test style, and so yeah, you can lack some quality here. And the test cases and the mocking in this style can get very complex very fast, because as you have seen, we have like a lot of test cases for one test method here, because we need to, for the calculator, for example, to test all the expressions and probably some variations of the expressions. And if you like consider a more complex scenario with even more external collaborators, for example, where you also need to handle mocks and stuff, this can get complex very soon. So what kind of test should we write then? Well, the answer is, drum rolls please. It depends. So if you know how to tackle a specific problem and the public interface is quite clear, the coarse-grained style might be a good way to go for you. And if you're trying to find the components to solve a problem, or even trying to understand a certain algorithm that you're trying to implement, yeah, the fine-grained style might be a good way to go. And also, you can a thing to consider is which tests to write versus which tests to keep. So while you're implementing a feature, you may probably want to test at a finer level of granularity, but once the implementation is done and you have proof that the code does what it does, you may probably only keep the interface tests. So the tests with a lower level of granularity. In the end, there are many things to consider, and probably a combination of both approaches can lead to a good and a reliable testing strategy. So let's end with a quote from the beginning here. It's a situational thing, and in the end, the team has to decide what kind of units sizes make sense for them and for their application and for their specific problems. So, thank you very much. Here are some resources, and behind this barcode you can again find all these links, so you don't need to memorize them here. Yeah, so I'm open for questions now.
Thank you, Sebastian. Very nice. We have some questions from the audience. Please.
You said in the fine-grained style that you are tempted to open up the API and also forced. So with tempted, is there a chance that I can use sealed classes? Because I really like the concept of sealed classes. Can I keep them? Is there something I can do, like you used to be able to mock static methods and classes as well with some code trickery? Is there something similar you can do, or do I have to use the coarse-grained style instead?
Question.
Yeah. So, the question is, in the fine-grained style, am I really forced to omit like the concept of sealed classes because you cannot really mock them, or can you do something similar like you can do with static classes, perhaps using Power Mockito or some other tools? I think this isn't really possible because the sealed classes are designed that you cannot like create more implementations of them that you have defined in the permits clause. And so one thing you can do to deal with this problem is just use a specific implementation. This is not then strictly following the fine-grained style, but if you like the fine-grained style more, or think the fine-grained style suits your problem or application well, then this could be like a way to go with this, and also keep your API closed. But yeah, you'll have then a pill to swallow, and that is that you probably will test some behaviors of other classes with your test class that you do not intend to test.
Great. Other questions from the audience here present? I've got one. The test pyramid is high. Right? We've seen it pass today on the talk of Jens. How could you apply these approaches to, let's say, integration or component tests?
Well, that is depends a little bit on how your component or your service, let's say, is structured. If you have a service that offers like multiple features, then you can probably use the coarse-grained style on a per feature basis. Or if your service or component just offers one feature or just has one public interface, like perhaps the lambdas that only have one public interface, then you can even apply the coarse-grained style to the whole component or to your whole service, like on an integration or component level. And for the fine-grained style, well, it is on class level, so you can just simply always apply it. You can also, as Jens said before on one of his slides, apply it on an integration level, like when testing REST endpoints or something like that. If you use this adapter pattern, then you can easily test these adapters with a fine-grained style.
Okay, thank you. I take a quick peek at the chat. Nothing's coming in. So that means that any questions that might be out there somewhere will have to be asked via mail or Twitter or whatever.
You can just contact me
For
by
now,
Twitter.
thanks a lot.
Thank you very much.
Yeah, maybe it's nice to have some final words for this session here. Sebastian already mentioned it. This talk was also came out of an article that was written and that was published on our OpenValue blog. Certainly something to keep an eye on. There will be some other interesting articles coming up. A big delegation of OpenValue went to Las Vegas a couple of weeks ago to the Java 1 conference, and there will be some learnings and some happenings described and published on an article there. So OpenValue.blog, very good to keep an eye on. Another one was FUJ. FUJ stands for Friends of OpenJDK. It's a platform, it's a community where there's a lot of information on OpenJDK. Very readable, also very nice articles. I think this one is also published there, and also something to keep an eye on. Obviously also our YouTube channel, where these talks will be published also. And that leaves us to, for a very big thank you to all the speakers, Sebastian, Jens, Christoph. Thank you for being here, everybody at home. Also thanks for watching. And if there are any questions, or if you want to reach out based on anything you heard, just feel free to contact us. And I would say for you guys, there is some stuff left, so just very welcome to continue the talking over there. Thanks.